hello children, how are you? I hope you are doing well. So welcome back to our channel. This is Rohit and you are seeing the Brilliant Mind classes. So guys, today we're gonna talk about a very important topic of class 10th mathematics of chapter 1, that is real number. So today we're gonna talk about how to prove root 2 is a irrational number, root 3 is a irrational number, root 5 is a irrational number, etc. This all question is same type, and there are various methods to solve this question, but we're gonna talk about the very easiest for examination point of view. Okay, so let's get started. There are various methods to solve this question, but what I am going to deliver you, just listen and tell me at the last how you just feel about this question. Okay, so let's get started. So today we are just going to solve root 3 is a irrational number. Okay, so listen and watch. So we're gonna prove root 3 is irrational number. This is a single type of question which is asked every year in examination, because this is the simplest question of chapter 1. So this will be important for your next board examination. Okay, so listen. So how we gonna prove it? So for proving this question, we just use a method, that is contradiction method. What? Contradiction method. Contradiction method. If spelling okay, just check out. Okay, contradiction method. What this method says? So this method is saying ki if we gonna prove anything, just we let that thing just opposite to his character. Means what? If we gonna prove irrational number to root 3, just we have to let it a rational number, and we just check out is it follow all the characteristics of rational number. If it follows, then it will be rational number. If it not follows, then we can say our contradiction will fail. Then after we can say this is rational number, this is not rational number, this is irrational number. You are not getting my point? Just we gonna what I'm just saying. In this method, we assume the number opposite to his character, number opposite to his character. Means what? If we have just irrational number, then we have to let it rational number, or we have rational number, then we have just let irrational number. We have to just let it. Okay, and see, this number is or this number is not same. Why? Because this number is integer. What I'm going to say? Integer. And this is rational number, fractional number, sorry, from my side, fractional number. So guys, integer never be equal to integer, not will be equal to fraction. Hope you are getting my point. Okay, so if we see anywhere a integer is equal to fraction, then we can say this is wrong, bro, and we can say this will be happen in any cost, because his denominator is 1, his denominator is 2, it will be not equal. Okay, listen, and one thing, rational number and irrational number is just two side of real number. The rational number will not equal to irrational number. So this is two result of contradiction method. So let's get to prove this. Okay, so let what we have to just let if it is irrational number, then we have to let rational number. Let root 3 is a rational number. Okay bro? Okay, and if you know, then rational number is always written as p by q, where q is not equal to 0. I am right or wrong? Am I right? Okay, so if we just let this number is a rational number, then what we can do? We can write it as p upon q, where q is not equal to 0. And here p and q is co-prime number. Means what? Both have SCF1, co-prime number. Okay, so now we're gonna just squaring both sides. Our next step is squaring both sides. Then what we can get? Then root 3 ka square p upon q ka square. So what will be the happen? The root 3 ka square is equals to 3 and p ka square is equals to p square upon q square. We have to just become a clever student, or just write q square in the form of q into q, and one q just will be transferred this side, the 3 q upon p square by q. Now we have to just focus on this. His denominator is 1, his denominator is q. Then what you can just realize that it is a integer, or that the RHS side is fractional, or it will never be equal to each other due to contradiction method. Not contradiction, but it not will be equal at any cost. लिखेंगे since here 3q is an integer number, and p square upon q is a fractional number, and it will never possible, या कभी possible नहीं होगा, it can never possible, and it can never what's listen here 3q is an integer number and p square by q is a rational number, and it can never be equal. If it never be equal, then what we can say? So our contradiction यानी हमारी जो मान्यता थी, that root 3 is a rational number is wrong, is not acceptable. Therefore root 3 is a irrational number. Then it is proved. Therefore root 3 is a irrational number. Okay, so this is the proof of root 3 is a irrational number. If question said how to prove root 2 is a irrational number, then we have just do nothing. We have to just erase it and just write 2 everywhere. Okay, it will be proof of root 2 is a prime irrational number. If question says root 5, then it is easy. Root 7, it will be also easy. Okay, so hopefully you are just getting my point. What